Welcome to Siniat's introduction to thermal boards. We're all experiencing large energy costs in gas and electricity. We can help reduce these costs by using the thermal boards. We all lose heat through our walls, through our windows, and especially in the loft area. The UK government are taking steps to improve the thermal efficiency of new and existing buildings. In England and Wales, through Part L of the building regulations. Northern Ireland, it's the technical standards, F1. Scotland, technical handbook, domestic, section 6. The government regulations are stated as U values. So what is a U value? It's a measure of heat loss through parts of the building, your walls, your roofs. No individual element has a U value, but it will form part of it. All elements of the wall construction form part of the U value calculation. Our technical service team can calculate your current U value of your wall construction, but there's information that they'll need. Is the property rendered? Is it rendered onto brick or block? Does it have a cavity? Is the cavity insulated? Internal wall, is it brick? Is it block? And is it plastered? Given that information, they can actually calculate your current U value. We can then calculate from the range of boards and thicknesses which one you should use to meet your required U value. Siniat has 4 thermal boards in its range. These vary in thickness, but are all laminated to a 1200 by 2400 plasterboard. We first of all have the basic EPS. This is basic polystyrene laminated to a plasterboard. We then have XP. This is extruded polystyrene. Moving up, we then have thermal PIR. Now this is actually laminated to a vapor barrier as well, and is a much higher grade foam. And finally, we have thermal K. This is phenolic foam, and like the PIR, also has a vapor barrier. What is a vapor barrier? A vapor barrier is a metallized foil laminated to the back of a plasterboard. The insulation is then laminated to this. It reduces the risk of condensation occurring in the cavity. Both PIR and thermal K have this. So where would you use it? Loft conversions, cellars, solid walls, and even garage conversions. I'm now going to take you through the methods of installing thermal boards. There are 3. There's independent wall liner. As the name suggests, it stands completely independent of the existing background. Examples of this are stone walls in barn conversions. We then have the dry liner system. This can be used on solid walls. Because it's a solid wall, there is no cavity, so we need to create a cavity, but the walls are fairly true. And finally, we have direct bond, which is actually sticking the plasterboards to the wall, using the Siniat universal bonding compound. I'm now going to demonstrate how we fix a thermal board using the direct bond method. It varies from fixing a standard wall board. There are a few differences. One of them being, we have to use a nailable plug. This is a secondary fixing required for fire safety reasons. Bucket trowel, or you can use a gauging trowel. You'll see me using both. Tape measure so you can cut your plasterboards to length. Hammer for knocking home are nailable plugs, and a saw, because unfortunately using thermal boards it's not a cut and snap. We will have to saw the boards to length. And finally, a drill, cordless or otherwise. This will be used to drill our holes for our nailable plugs. And one final thing, a straight edge. This will be used to get the board level and true. Now for the demonstration of installing a thermal board. What you will need to know is it's actually the handboard that puts it on the trowel and not vice versa, for those of you who have not done it before. Some of you have attempted a bit of plastering or attempted direct bond before and probably finished up with most of it on the floor. What you try to do is that. In actual fact, if you give the hawk or the handboard a little shake, it won't come off. You can then take your trowel across the surface. As you get to the edge, press on and take it off. We haven't dropped any. And our dab is the correct size. It's between 230, 250 millimeters in length, and it's between 50 and 75 millimeters in width. We can now apply this to the wall. You'll notice there is a difference between fixing standard wall boards and thermal boards. You need 4 rows of dabs. And because it's on an external wall, all the perimeter of the wall will be completely sealed. And also any window or door openings. Around those, again, you would completely seal them. With the dabs now installed, you can see I have a continuous ribbon at the ceiling wall angle, the internal corner and the skirting line. It's also important that the dab centres are 300 millimeters apart, not 300 between the dabs. We've got sufficient dabs. We're now ready to place the board in position. So, with our board cut to size, I've placed a couple of packers on the floor. The reason for that is, remember, no plasterboard should ever be in contact with the ground in case any water is spilt or there's a leakage, anything like that. Gypsum loves water. Place the board on the packers and nice and tight into our internal corner. Just resting the board against the dabs. We can now use our straight edge to level the board. The hollow, you see I have here, which means at the top and a little bit at the bottom need to go back. Across to the corner, and I can see that the bottom obviously needs to go back. Do the vertical. Check the centre of the board. And then finally check going across. I'm now ready for the next board. Silver's top tip. The nailable plugs are better done the following day. That way you can guarantee that your bonding compound has had time to set and dry. The reason for that is when you're fixing these, you will need to drill into the board, and you will also need to knock them in to place using a hammer. And doing that while the bonding compound is still wet is going to distort the board. So now, the following day, we can see that our bonding compound has set. So we're ready to install our nailable plugs. What length do I need? The rule of thumb is 50 millimeters plus your board thickness. That means the maximum dab thickness you can ever have is 25 millimeters, and you need a minimum of 25 millimeters into the masonry background, hence where the 50 comes from. Plus the board tells you what length you require. If your measurement actually falls in between the lengths available, you always go to the next size up, never down. They go 300 millimeters down from the ceiling and 25 millimeters in from the board edge. So we can measure 300 millimeters down from the ceiling and 25 millimeters in from the board edge. It's 2 per board.
So you will need to do that on both sides.
I'm now ready to drill and put my plugs in place. With my holes drilled, I can now place in the plugs and tap them home. With our boards now installed, you can refer back to our video on taping and jointing. Happy building.